Hi there, this is Azil Maksud. How are you everyone? Today I am here with a high-level project, three-tier application deployment with EKS best practices and EFK logging. Lots of projects I have very tough situation. This is one of those. When I learned this one, when I did the practices, honestly, it has given me super tough time. And this is also very much demanding project in the job market. I hope this project's overview is like that. It will demonstrates the deployment of a scalable and secure three-tier application on Amazon EKS Elastic Kubernetes Service following best practices. Okay, best practices should be, and additionally it incorporates centralized logging using Elasticsearch for Fluentd and Kibana. Fluentd or Filebit, same thing almost, and Kibana is the dashboard stack to ensure effective monitoring and troubleshooting. And this one will be uploaded here. This is my repo, DevOps 0 to Hero. I will upload this one, not tonight. I will upload this one tomorrow maybe. Okay, so let's go to the real project first. Of course, first of all, I need to create the bastion because I'm not using the local anything else without bastion. Yes, you can use also minikube in your local system if you like, but I'm using Ubuntu EC2. I have the keypad. If you don't have, please take from here. And I'm using my security group, default one. Okay, I'm good with this one. Yes, it looks running. It's still initializing, but I need to create first connection. So I'm creating first connection here with Mobextrum session SSH, Control V the IP, Ubuntu for CentOS. Other thing is EC2 minus user. Private key I have used default PM, right? Okay, it's connecting. Now I'm doing something pasting, so you can go in my paste repo. If you go through paste repo, I have used here which one I am doing. So already I have taken the copy this one. So first of all, update and fully upgrade. This is very much important for the production level. If you don't do the fully upgrade, then sometimes it makes problem. Not only upgrade, fully upgrade. Then CLI you have to install. First of all, you have to install the unzip, then CLI install. Then you have to go like that way. Okay, it's doing still. So after CLI installation, then kubectl installation, then EKSCTL. So kubectl, EKSCTL, and AWS CLI. These three guys will be installed here. It will take a bit time. Yes, it looks done. Control L. So first of all, let's see AWS version. So how to see AWS space hyphen then version. This is also interview question. So CLI 2.22 something, Python 3.12 the latest one. Linux it has the Ubuntu 0.24. It's everything goes. x86 is good. Then kubectl. See here something interesting I'm showing. Kubectl CTL, then just version, right? So kubectl version you can see here, client version 1.32.0, customized version v5. So localhost 8080 was refused but didn't. Okay, it's okay. So also EKSCTL, let's say kubectl version, EKSCTL version, EKSCTL 0.199. So see here we had to say, and version for AWS we had to give which one, space, then hyphen. So AWS needs a space, this hyphen, but this guys does not need the hyphen. This is a tricky interview question. Now I have to do AWS configure. I need the access key ID, secret access key. So for this reason I have to go AWS identity access management. I am users. I have to create one more user for today, EKS user. I'm giving the name like this one. Okay, attach the policy. I'm giving the administrator access. Next, create user. User need just policy. So I got the EKS user here. So I need the security credential. I have to create access key. This is for CLI, right? Okay, then I have to confirmation. Next, then create. So in the real time you have to download this .csv file. So now just I'm taking from here because after this demo I'll just delete. Okay, secret access key. I can show you, no worries. I'll delete it. Okay, region US East one I'm using. Okay, then output is JSON. Now let's see AWS S3 ls connect. Yeah, I have this guys, so it's good. Now I have to create a cluster. So sudo vim, or I'm giving nano cluster.yaml. Okay, so just I have put here this API version kind cluster config. Metadata name I have given December 24, EKS today is 19. So this is region US East 1 node group, and name is ng1, instance type d2 medium. It means some bigger instance. Then desired capacity 3 I have given. You can give anything else. Volume size 20. IAM, identity access management with OIDC, open ID connector, should be true. Add-ons has which one? EBS CSI driver, which connect with persistent volume claim in the pod level. Okay, so this EBS CSI driver very much important. Also OIDC connector, IAM, these two guys very much important with node. It should be true. Okay, then control O, enter, control X. This is the nano command. Now I have to do which one? EKS CTL create cluster, then hyphen a file. Which file? cluster.yaml. We just taken, right? It will take 15 minutes. I'm coming back. Yes, it looks good, everything, but you need to see kubectl get nodes or node. Either way it will be working. Yes, node has been created 3. Let's go here. Our cluster created here. It's good. Version 130. And let's see the EC2. EC2 has the node. It should be 3. Okay. So instance is coming. Yeah, 3 and 1 bastion, so 4. Auto scaling group is working. Elastic IP also created. Okay, everything's good. So here it is. Yeah, 1, 2, 3 and bastion, so 4. Looks good, everything here. But every time I cannot run kubectl. To avoid this one, I have to edit bash rc vim, then tilde slash dot bash rc. Okay, insert. I'm just inserting this guy's alias k equal kubectl alias kgp equal kubectl get ports alias kgs equal kubectl get service. So this 3 guys is more than enough, I think, for me. You can add also if you like more. WQ. Okay, now kubectl get port KGP. If you see, it's not showing any port, but if you see the namespace cube system default one, we can see because it's still not our basher seed not working alias, because we have to say source now should be working. Yes, kubectl get port namespace cube system. So inside the cube system, here is the node 123 core DNS 12 EBS CSI driver and kube proxy is here. Now the time for deployment. So first of all, backend deployment I have to do. So this is the command k means kubectl create deployment backend, then space -- image. I have taken this image from my Docker Hub. Output is YAML -- dry run client and appending this one to backend.yaml. So arrow, this arrow greater than arrow is that, and I have taken this one from here. This is my Docker Hub. So I have taken this image here, 2-tier backend image and front-end image also I will take. So let's see here. Okay, backend.yaml is created. We have said that we need the name like this, backend.yaml. So backend.yaml is created. We had earlier cluster.yaml. So let's see the backend.yaml. So it has given deployment, create deployment, right? It has created the deployment. Metadata, API version, kind, metadata, spec, these four guys. So create timestamp null, labels, app backend, name backend, then spec, replicas one, and selector, match label, app backend, strategy, template, metadata, creation, timestamp, null, labels, app backend, spec, containers. Image is here has come, which one I have given here image. Then name 2-tier backend image. Inside this image, I had used the 2-tier backend image, this name inside this image. So this name should be same whatever I have used. Then resource, this is the variable status, this is like that. So here is the very much important thing is that kind, deployment, and spec. Inside the spec there is the nested spec. So spec here the container, this is important. So see here spec, then this is the parent, this is the child, right? This is the child. So in the template, under the template is coming the container in the spec. Okay, so parent, child, grandchild spec is coming the grandchild like container. So this is important. Under the template is the container. Under the template the spec, that is spec has container. So this is important in the interview. Now I have to add in this deployment backend.yaml. I have to add something under the container. Let's see that I have to do. I'm doing Vim this one. Okay, then insert container name, then here I am adding environment and these lines for environment. So environment name MySQL host, value is here, then name MySQL user, name MySQL password, name MySQL DB. Everyone has name and value, key value type. Okay, environment. So this environment has been added. This is actually the database environment. This is also interview question. After creating the backend deployment, how do you add database? Database is added in the container in the backend.yaml as a environment. Okay, please memorize this or remember this one, please. Very, very important for the interview. Okay, so after having anything changes, we have to do kubectl apply, right? Okay, apply -f, which one? backend.yaml we have changed. Okay, so this is created. We can see again get backend.yaml. Yeah, this is same. Now let's see kgp kubectl get port. So backend port is working. We can see also kget ns namespace. We can see here. So default kube node list, and here is kube public kube system, the namespace. Now I have to install Helm chart. So Helm is the package manager. I'm using Ubuntu Debian. So I'm taking from here these commands. So it should be install Helm. Yes, it looks installed. Now I have to edit. Let's see how many files here. Backend.yaml, cluster.yaml. Now I have to add one more file. That one is values.yaml. I'm doing nano. I like nano also, man. Values.yaml. So I am giving the authentication file here. Root password hello 123. Create database throw database 2-tier backend db. Username secure user. Password I have given like this, very secure password. You can change in anything else. Control O, enter, Control X. So here is how many now? values.yaml with 3, right? Okay, so I have to add some storage. See, let's see without storage I can do or not. So first of all I have to add the bitnami chart. Bitnami chart for installing MySQL. Helm repo add bitnami. Okay, successfully happy helming. Okay, I like this word. So after having this one, I have to pass this one. Helm install MySQL. Helm will install. Maybe you can think like that. I install MySQL. Okay, Helm install MySQL. This is the path. Then -f file values.yaml. This file values.yaml we have created. Following these values.yaml authenticators, it will be created. Okay, it's creating. Looks like it has created. Okay, username root, MySQL password, it has given like this way. Namespace default. The default namespace it has. Control L. KGP. Let's see here. It's showing pending because storage problem. Oh my goodness, it needs storage, lots of storage, man. So for this reason I have to create one storage, beam storage.yaml. I'm doing nano. I'm adding storage.yaml. Okay, so I'm adding this one, kind storage class, metadata name EBSSC. EBS storage class, namespace MySQL. Then on annotation is coming like this way. Provisional EBS CSI aws.com. Parameters type GP2. Okay, so yeah, EBSSC. Control O, enter, Control X. Now I have to active, right? Apply. Okay, apply. I have created but not applied still. -f file storage.yaml. It should be applied. It's applied. See, still KGP should be pending because I have to delete first this one. So Helm uninstall. Install, that means uninstall. Have to uninstall. Yes, this is uninstalled. Now KGP, let's see here. Yes, no more that one. So I have to install again the command I have to do. I have to install. Okay, now see KGP. It's working now, man. See, MySQL now running. It will be ready. So if you see the pending here, if you see the status pending, that means most of the times for the storage class. Okay, I'm feeling good now. Let's see the service also. KGS, QCDL get service. Okay, here is MySQL. MySQL service is showing here. 3306 port is working. It's good. Let's see KGP again. So let's go inside the backend. Okay, kubectl exec -it. Then this one, the name of the backend then bash. Okay, so in the root backend, yeah, it starts the app. Let's see environment. Here's the env environment. So whatever we have inserted inside the password, then user, everything is showing up here. So important thing is that yes, 443 is working port. Okay, service host, everything is nice. 3306, I was searching this one, MySQL port. This is very much important. Kubernetes service also important, but from my concern, 3306 is important. Okay, so exit. I have exit from there. Control L, KGP. Now let's go inside MySQL. K exec -it, then MySQL pod name bash. So now I'm inside the MySQL. So MySQL -u, MySQL -u, that means user. Which one was user? Our user is at the backend, right? Backend pod has the user I have given. I'm connecting from here. MySQL user, this is my user, right? This is my user. -p, that means password. So which one is password? This is the password, right? Very secure password until this. Right click. Okay, connected. Okay, I have showed this environment for this reason because I sometimes make mistakes. You will also do mistake, man. Okay, so please see the environment in the backend. You can see the password, username, everything is there. Okay guys, now we are inside there. So show databases, we can see here from show databases. Yes, this information schema, performance schema default, and two-tier backend DB. Database name, I have given the database name. Can you remember here? MySQL DB name, two-tier backend DB. So this is the database name, right? So I have to use this database. Backend DB : okay, database changed. Control L. So now I am inserting two tables, user and history. Okay, I just paste here. Create table users, ID integer not null, auto increment, then email varchar variable character not null, password varchar until 100, character not null, primary key. So first table query is okay. Second table query, second table here is history. So history table, it is coming like this way. I'm not going that. So last is show tables. It has two tables created, history and users. So I'm good now, but I have to insert something, email and password, that means key value system, so I have inserted this, insert into users, this one, users, which one I have inserted, email and password. This is the key, then values. Here is the email user1, example like this way .com, and password is hello123. So yes, then the query select star everything from users. So users table, everything. Then I have to say everything, which one ID and email has, ID, email, password, ID1 incremental, and email, password. ID is incremental, I have given, right? Can you remember ID? Auto increment, see here, same auto increment. If you give the auto increment, it's coming 1 2 3 4 like that way, adding just. Okay guys, so exit from here, then exit from there, exit from MySQL, exit from pod now. Okay, Control L. Now I'll run the backend application with the help of config map to serve the environment variables. So I have to add, first I'm doing nano db config, I'm giving db hyphen config dot YAML file. Okay, so API version v1 I have given kind config map, then metadata name MySQL config, data MySQL host mysql.default.service.cluster.local, then MySQL user, secure user, I have taken as changed the user, maybe this one changed, password, very secret password, database, two-tier backend database, not changed, same thing. Okay, so Control O, enter, Control X. So this is created now. So after creating anything else, we have to apply, right? K apply hyphen a file dbconfig.yaml. So if you apply it, if this is created, right? If not created, that means your YAML file has the something problem. Okay, now actually Kubernetes knows this file is inside there. Okay, now I can get the config map now. Okay, get config, because I have used something, that config map. Let's see here. See here the config map. After applying dbconfig MySQL config hyphen config, it has been created. So we can see get dbconfig. We have given the name MySQL hyphen config. This one is here. Okay, inside the config map. So everything looks good. Now I can see cm MySQL config output YAML in the YAML also. Okay, get cm config map. So which one? The config map here, this one, right? And output, I like YAML, right? Okay, now I can see inside this inside this one. This is not. I'm making something better looking. Okay, so k get cm config map, this config map in the YAML. This is the information, MySQL DB, two-tier backend DB, host, this is the host I have given, right, inside the config map. Password, this is user, this is kind config map, this is the metadata annotation, everything is here. Okay, looks good. Name config map default, everything looks good. Guys, now I have to add this config map in my deployment. Okay, Control L, then Vim backend. Our deployment name is backend.yaml, right? So under the name of the container, where is the container name? This one, right? So earlier was environment, now I'll do environment from. I'll take the environment from, just I'm deleting everything, insert and okay. So now environment from, see here env from which one, config map reference, name MySQL config. So guys, this is a granular way I'm showing you how step by step we are just proceeding to everything. So config map ref, so control okay, ask wq, okay, it's done. So everything changes, then k apply, kubectl apply -af, which one backend we have changed, right? Yeah, that means configured, that means now Kubernetes knows these changes happened. Let's see kgp, see here backend, this one is creating and this is running the older one, which one, tg last, right? tg older, lnk is new. This is the zero downtime, see something I'm showing you, zero downtime. So the new one, right, lnk is running, older one is terminating. Now let's see the new backend port, kexec -it, backend port name, new one which I'm running, right, -- bash. We are inside now env, you can see the environment. So everything looks good, 3306 password, this is everything looks good. Okay, yeah, so whatever we have changed, everything also in our new port. So we have to ensure this one, you have to come many times here. So exit. Now I'm adding some resources in the backend. So Vim backend, because backend needs more memory. So containers, insert and container image. So memory, anything is adding or everything to the images, you know, spec template, image template in the spec. Okay, then it's coming like this way. So these resources memory 50 MI, CPU 100 M, and limits memory 1 GB byte, CPU 1 CPU. So here with the containers, please keep in mind, with the containers I have added memory resources and environment from config map, MySQL config actually. So MySQL config and also memory I have added, memory as resources, MySQL config as environment from. So this is important for the interview. Ask wq, if anything else then change, then k apply, without apply not working, right? Which one we have did, backend. Okay, it looks configured, that means it's good. Okay, so let's see kgp. Yes, our backend and MySQL both are running, so there is no problem with this one. So let's see the backend port. We have to see inside k describe. Now we are doing describe, then port, backend port. Okay, let's see here. Okay, describe backend port. Our command is from here, right? Okay, name backend, default namespace. Okay, everything looks good. Okay, annotation none. IP is here, it's working. Image ID, everything looks good. Running ready is true. Okay, pod ready to start containers true. Initializer initialized to ready, everything good. Now I'll create a custom Helm chart for the two-tier application. Then I'll run there. Okay, so Control L. I have to create first Helm create two-tier. I have given this name. Let's see Helm list. Okay, this is the Helm list. MySQL default ls. So Helm has created two-tier here. See here, we have given the two-tier, right? Two-tier. Then let's go inside two-tier ls. So when creating Helm and its custom chart, then it's create four things: chart.yaml, charts, templates, then values.yaml. I don't need the charts, these charts. So just rm minus rf, because this chart is actually directory. ls. I have now three things: chart.yaml, templates, values.yaml. So now I have to go inside the template. cd templates. Control L inside lots of things, right? See, Helm create the custom, many things given. Oh my goodness, deployment.yaml also here. SPA ingress.yaml from outside connection, service.yaml for inside load balancing. Okay, then service account.yaml tests. Also one default folder has given. Okay, so I don't need anything else. I have to delete everything from here because I'll customize this one. rm remove, then hyphen rf, then space dot slash star ls. Everything is removed. This is interview question also. If you like to remove everything, then rm space hyphen rf, then space dot. This space dot means everything from inside, slash then wildcard you have to give. Okay, so wildcard has taken. Now I have to go back one step back, cd space double dots. Okay, so now I'm in the two-tier, right? So here let's see the two-tier, which one has these three guys. Okay, so I have to edit now. Beam chart.yaml, beam chart.yaml, I have to edit. So after editing, I'm passing my configurations. Okay, this is default one given by Helm create. Okay, I'm cleaning. Then API version v2, I'm given name to tier. Okay, the chart.yaml, I'm giving name to tier. Then description, a Helm chart for two-tier application. Type application. Okay, version, this is app version, this is the application type. This is very much important, man. Okay, then sk colon wq. So now I have to go back home directory. Then I have to copy lots of things. cd control l ls home directory. I have lots of things. I have to copy cp backend.yaml first because I need the backend.yaml. I don't use the backend.yaml, has been given by Helm create default one. I'm taking my one, backend.yaml. So also I need the db config.yaml. This guy, these two guys copied, and it should be in the two-tier templates. Okay, two-tier slash two-tier inside the template, right? Okay, now cd two-tier templates ls. See guys, the two-tier template, earlier I deleted everything, right? So now this is backend.yaml db config. These two guys are here. Okay, now I have to change the name. How to change the name? I'm changing the name of db config.yaml. Actually, in the shell you have to move one file to another file. That is the changing the name, and I'm giving the name like MySQL hyphen config map dot YAML. Okay, now let's see the names. Earlier was dbconfig, now mysql config map.yaml. Okay, so it's good. Now let's go one step back, the tutor. That is the values.yaml, right? So in the values.yaml, I have to edit the values.yaml. Beam values.yaml. So this values.yaml, I have to delete this one. This is by default values.yaml. Okay, insert. Now I'm inserting my one values.yaml. This one, replica count, one image backend repository. This is to go. This is my GitHub latest front end. Okay, this is that. This for backend and front end. I have given both. Okay, here values.yaml file ask wq. So in the tutor ls, so tutor, I have changed the values.yaml. I have changed templates. I have changed the chart.yaml. Right? Let's see cat chart.yaml. I have given inside this one chart.yaml. I have said that which an application should be, the type application I need. Okay, this is the chart, application chart I need. Then values.yaml, I have just changed my configuration. I have given the template folder. I have added my things, right? Tutor, the templates ls, I have added these two guys in the template folders. So Helm create tutor. So by default everything is changed. Please keep in mind which one I have done. So cd templates, let's go to the templates, control L, ls. So I'm editing here backend, then the replica count, I'll make this variable. So beam backend.yaml. Okay, I'm changing something, replica count, replicas. There I'm adding something. Here the replicas is one, right? So if I don't change here with this one values dot replica count, this is the variable. So whatever I'm changing in the Helm chart, there it should be just automatically changed replicas. And also image, I have to change the image. Same way. Where is image? This is the image, right? Okay. Image. So I'm adding this one values. So everything will be taken from values.yaml file. See here, this one also replica will count values.yaml. Then replica count. This one also values.yaml, values image backend repository values event backend tag. So these two guys are changed only. Okay, ask, then column wq. Okay. Yes, so this is deployed now. It's good. Looks okay. So let's see the Helm list. So Helm list MySQL new tutor. I have created this one, right? New tutor. This is also created now, also deployed. Let's see the KGP. Okay, both are running. Backend also running 36 seconds. Let's see the config map. kubectl get cm. Okay, MySQL config, MySQL, everything looks good. 54 second MySQL config map has been created because this tutor has been created. Okay, so I have to edit the values.yaml file inside the tutor directory. Then I have to change the replica count because values.yaml file I have the replica count, right? So beam values.yaml is where tutor, then values.yaml insert. So replica count is here. Can you remember values.yaml, the replica count we have given the our main deployment, backend deployment, we have given the variables for replica count. Also backend and frontend images, we have given the variables. So now I am given the replica count 3. It will count from here, WQ. Okay. So after changing anything else, maybe your manager said that change the replica count 3, should be 3, like that, 4, 5, 6, 7. Then you have to do a Helm upgrade. Okay. Helm upgrade. Then which one should be upgraded? Our new 2 tier, right? New 2 tier we have given. New 2 tier, then dot slash 2 tier, then hyphen. Okay, just without that I can do that. So this is upgraded now because we have changed there. Let's see now KGP. See here, we said that we need how many? 3, right? Backend 1, 2, 3. So 2 running. Okay, let's see something bigger. KGP. Now all are running. So our backend pod is now how many? 3. Okay, so we can change the upgrade state from here using the replica count without changing our values.yaml, like set replica count. Replica count is C is bigger, caps equal. Let's see here, manager said no, not 3, I need 5. You don't have time, man. Just do upgrade like that. KGP. See here, how many? 1, 2, 3, 4, 5. It's running. It's so quick, man. Yes, for this season I like Helm chart. So this is the time for our front end. We have to create the front end deployment. ls. We have to go to cd 2 tiers templates. Templates has our backend.yaml, right? So here we have to create also the frontend.yaml. kubectl create deployment frontend -image nginx output YAML diagram like this way. Can you remember any image? If you can write here, it will count other way. Then everything should be in the frontend.yaml. Frontend images nginx I have given here. Okay, so in the frontend I have to change something. Beam frontend.yaml. This is just created. Same way replica count, I have to give the variable. Also image insert, our replica count is 1, right? Okay, this is the for front-end replicas. Then image, container image, nginx, container image, ask wq. Okay, so these two guys are changed. So now I have to do Helm upgrade. Anything changes in the template, I have to do upgrade. cd upgrade the our Helm file to tier. Control L ls. So Helm upgrade. Then new 2 tier we created, right? New hyphen 2 tier dot slash 2 tier. Okay, this is now upgraded. This is done. So I have to do expose. Without exposing, I cannot do anything else. Let's see the KGP first. See here, front end is not running because it's not exposed after upgrading. Back end is running, but front end not running. Okay, so to run the front end, I have to do expose for back end and front end both. So I have to go there inside the 2-tier cd 2-tier / templates. So Control L ls. So I'm here, templates. So I'm exposing here like this way. kubectl expose deployment. So create deployment, then expose deployment should be done. So backend exposing. Okay, then name backend service, port 5000, YAML output like this way. So this is the backend service will come. Okay, backend services come ls. So same way I have to expose the front end deployment. So after exposing, the service is coming. Okay, kubectl expose deployment front end, name front end service sbc, port this way, node port, dry run. Okay, this is done. ls. Okay, so now let's go back. Control L. So if the error coming like this way, now see, crash loop back off. Earlier was error, right? Because if not exposed, if there is no service, then error. Now we have service, but it is crash loop back off. Crash loop back off is coming because the existing, the new 2-tier Helm, that one should be now uninstalled. Then I have to create another one. Then it will become up. Helm uninstall new 2-tier. Okay, it's uninstalled. Let's see now KGP. Every changes I am showing you. So when uninstalled, that means see terminating. That means no backend port will be here now. KGP terminating, it will be go out. So now I am installing with Helm again. I'm giving the name like 2-tier, like my 2-tier, like this way. Okay, new one. I'll create from /2-tier. Okay, Helm. Oh, my bad. It should be installed, man. It's night time. Need to sleep. Okay, it's deployed. Okay, so KGP. See, man, it's now running. Oh la la. So backend is 3, front end is 3. That means 6, right? 6 are running all. Now let's see KGS, get service. See here, node port, front end node port 32,450 has been given. Backend cluster IP, Kubernetes cluster IP. Okay, so here is, I need this one. So let's say I have to, in our node here, I have to change the security port first. Security group. Okay, so edit inbound, just add role here, all traffic, anywhere, save roles. This is done. Go back EC2. So this is EC2 detail, public IP, Control V colon. Our node port was how much? 32,450, right? So it should be 32,450. Say our application has come back. application come back, man. It's working also. So this is working good. Now I have to incorporate EFK stack for logging. So first of all, I have to create the namespace for EFK stack. I'm giving the first kcreate kubectl create namespace logging, then kubectl config set context.